हेलो माय डियर मैकेनिकल चैंपियंस, हाउ आर यू ऑल? व्हाट्सअप, कैसे हैं सब लोग? प्लीज गाइज डू ज्वाइन मी फास्ट बिकॉज वी आर गोइंग टू हैव very important session for ISRO 2023. So that session will be all about conduction and heat exchanger, formula revision as well as some practice questions. So those who are watching me live, please do respond through the comment section if my audio and visual quality are fine. नमस्कार, आदाब, सुप्रभात, good morning, सत श्री अकाल, अस्सलाम वालेकुम, वणकम. Please get yourself settled down fast. As you can see over the screen, the session is about the subject heat transfer, and in the heat transfer subject we are going to cover two very important topics which can be expected in your examination. That is, conduction covers 60%, more than 60% of your heat transfer syllabus, and the heat exchanger, though the topic is very small but is very important for your all the competitive examinations. आवाज आ रही है मेरी? नरुतो, वेलकम. विनय, गुड इवनिंग, गुड मॉर्निंग गाइज. How are you all? How is your preparation going on? So shall we start? Please make some noise so that others can also join this session and get benefited. Hi Patel ji, how are you? Welcome. So this is my quick introduction for those who are watching me for the very first time. मेरा नाम चंद्रशेखर है. I have done my graduation from IIT Delhi in 2006. I have also cleared engineering services examination in 2009. I had worked in Steel Authority of India Limited for a couple of years, as well as I have worked in a private consulting firm for more than 2 years. So my total industry experience is more than 4 years, and the rest of my experience is completely into teaching. I am guiding the students from last 10 plus years, or it is close to 11 years for those who are preparing for various competitive examinations like GATE, IES and other PSUs. I am quite comfortable in these many subjects of mechanical engineering. If anybody is having anything to ask, anything to discuss in any of the subjects, you can always connect with me through the mail ID chandra.shekhar7@byju's.com, or you can join me on the Telegram as well, which is Mechanical by Chandrasekhar. The link is also given at the bottom of the screen. आप टेलीग्राम ग्रुप को फॉलो करेंगे तो यू विल बी गेटिंग द अपडेट्स अबाउट द वेरियस एग्जामिनेशन नोटिफिकेशंस, as well as the PDF and important session updates will also be given to you through the Telegram channel only. All the important information for your examinations will be provided to you through the Telegram group. Moreover, you will be getting some questions to practice, as well as your doubt clarification will also going to happen. मनीष, बहुत ही उम्दा सवाल है जिसका जवाब हम भी ढूंढ रहे हैं काफी टाइम से. What will be the expected date for ISRO exam? अक्टूबर में होना चाहिए. After 2 months, either after September 15th to October 15th. Any time it can happen between September 15. That is my guess only. I do not have any official information. That is my assumption or my opinion. But you never know. Anything can happen at any moment. So you should keep your preparation complete, so that you should not be lagging behind your competitors. All right. Yes, there is an important announcement. Tomorrow at 7:30 p.m. there will be a live interactive free workshop conducted by Abhinav Negi sir, who is MTech from IIT Delhi, having more than 11 years of vast teaching experience. he will be going to discuss the master plan. Yes, to the master plan to secure or to clear the GATE 2024 examination, even having the 6 months of study. All right. So do not forget to join this workshop, and to join this workshop, please do register yourself through the link which is mentioned in the description box. And do not forget to like and share this session, guys. This is very important for us, for all the students who are preparing for various competitive examinations, specifically those who are preparing for ISRO 2023. All right, and all the important links are already mentioned in the description box. मनीष, बताना तो चाहिए 1 महीने पहले, बिकॉज इट इज अबाउट योर करियर. इसरो के लिए बहुत ही छोटी बात होगी भले ही, क्योंकि हर साल इसरो एग्जाम कंडक्ट करता है एंड इट इज ए पार्ट ऑफ देयर प्रोसेस, बट फॉर ए स्टूडेंट it is the lifetime opportunity. So in my belief, at least they should intimate 1 month in advance for the examination. But you should not wait for the official notification. Keep your preparation in the final gear. Keep your preparation with your full dedication and enthusiasm, so that you should not regret for your future. All right, shall we start? चालू करें our journey. So we will start with the first question, very simple question. In conduction, we always analyze 3 types of system. The system is in the form of a plane wall, the system which is in the form of a cylinder, hollow cylinder, and the system which is in the form of a hollow sphere. So we analyze the conduction in detail for these 3 types of system. So in the list 1, there are systems, various systems, and in list 2, the thermal resistance is given. The analysis of heat transfer is done by using the circuit diagram or electrical analogy. Let me know A, for a plane wall, which is the correct expression for thermal resistance. For A, बताइए. What about a plane wall? For the plane wall, the value of thermal resistance is L by Ka, A2. Very nice. What is the unit of thermal resistance? Who will tell? Quickly. Unit of thermal resistance. Very nice, Vinay. Plane wall, L by Ka. L is the thickness of the wall. K is the thermal conductivity. A is the area which is normal to the direction of conduction. Then hollow cylinder. In case of hollow cylinder, it is ln of R2 by R1 2 pi KL. Yes. We can find out the unit of thermal resistance from this expression, delta T upon thermal resistance. So the unit of thermal resistance is delta T by Q. So it can be either called as Kelvin per unit watt or degree Celsius per unit watt. Both are correct. Kelvin per unit watt or degree Celsius per unit watt, both are correct. ठीक है? For a hollow sphere, R2 by minus R1 upon 4 pi K, R1 R2. R1 is the inner radius of the sphere, R2 will be the outer radius. Do not get confused with cylinder and sphere. If it is a convection, then convection is analyzed by using Newton's law of cooling. Newton's law of cooling. And according to Newton's law of cooling, Q is equal to H into surface area available for convection into bulk temperature difference. If we equate with delta T upon thermal resistance, Q is equal to delta T upon thermal resistance, then the thermal resistance will be 1 upon HA. So it will be 2134. 2134? Sorry, 2143. 2143. 2, 1, 4 and 3. Isn't it? 2143. Very nice. Yes, Parth. Definitely I will provide you the PDF of the session in my Telegram group. You should remember the formula. Look. The temperature profile for various system. Do you remember the formula for temperature profile? What is the nature of temperature profile in case of a plane wall? Who will tell me? The nature of temperature profile in case of a plane wall. T1 minus T upon T1 minus T2. That is given by X by L. So temperature as a function of X will be linear. The nature of temperature profile will be linear in case of a plane wall. In case of plane wall, this is the formula. In case of hollow cylinder, what is the nature of temperature profile? This is the nature of temperature profile in case of hollow cylinder, isn't it? Right? What is the nature? Nature is logarithmic. Yes, for a hollow cylinder. And the nature of temperature profile is 1 upon R1 minus 1 upon R upon 1 upon R1 minus 1 upon R2 in case of hollow sphere. The nature of the temperature profile is hyperbolic in case of hollow sphere. But these formula are valid only in case of one-dimensional steady state heat conduction. These formulas valid only for one-dimensional steady state conduction with constant thermal conductivity and no heat generation. If these conditions are or these assumptions are taken into consideration, then we can apply these formula for temperature profile, right? And what is the rate of heat transfer? Q is equal to Ka delta T by L, that is equal to delta T upon thermal resistance. So we can say thermal resistance is given by L by Ka, that is for a plane wall. And what is the rate of heat transfer in case of hollow cylinder? 2 pi KL delta T upon ln of R2 by R1, isn't it? If we equate with delta T upon thermal resistance, we can find out the value of thermal resistance for a hollow cylinder. What is the expression for Q in case of hollow sphere? 4 pi K R1 R2 delta T upon R2 minus R1, isn't it? That is equated with delta T upon thermal resistance. We can find out the expression for thermal resistance in case of hollow sphere. These are the important formula you should memorize. K is the thermal conductivity, L is the thickness, and in case of cylinder, L is the length of the cylinder. I hope this is clear to everyone, isn't it? Let us move further. How the thermal conductivity varies with temperature? Do you have any idea? If K is not constant, K is a function of temperature. So how the thermal conductivity varies with temperature? In case of liquid or conductor or metals, the thermal conductivity decreases as the temperature increases. In case of gas or insulator or non-metal, the thermal conductivity increases with the increase in temperature, and in case of a gas, the thermal conductivity is directly proportional to root T. I hope you are aware about this. Hi Pejal World, good morning, welcome. Very nice. Money, well done guys, well done. Are you aware about that? Because of molecular collision and molecular diffusion as the governing factor. So if we draw the temperature profile for a plane wall in case of variable thermal conductivity. If the thermal conductivity is taken constant, it will be a straight line. But if the thermal conductivity K is equal to K naught 1 plus beta T, then the expression will be like this. And for K is equal to K naught 1 minus beta T, the curve will be like this. This is X is equal to 0. This is X is equal to L. Right? Let us move to the next one. Then again, an important concept. Whenever there is a heat generation in the system, there can be a heat generation in the plane wall, there can be a heat generation in case of cylinder, solid cylinder, there can be a heat generation in case of solid sphere. Whenever there is a heat generation, what will be the formula for maximum temperature in case of solid cylinder? What will be the answer? Tell me first, you tell your answer, then I will tell mine. Whenever there is a heat generation, then the temperature profile is parabola. Temperature is a function of x, is a parabolic nature. For a plane wall, temperature will be parabolic. And the rate of heat transfer is linear. If we talk about a plane wall, temperature profile will be parabolic and the rate of heat transfer will be a linear function of x. The heat transfer will be taking place in two ways. If it is a solid cylinder, then this will be the maximum temperature. Let us talk about the plane wall first with the heat generation. So the temperature profile is given by Ts plus Q dot x by 2K into L minus x. This is the expression for temperature profile. So we can say temperature is a function of x square, that is parabola. And at x is equal to L by 2, dt by dx is equal to 0. So T will be maximum. And the expression for maximum temperature is Ts plus Q dot L square by 8K. When Ts1 is equal to Ts2 is equal to constant. When the inner surface temperature and outer surface temperature is Ts, then dt by dx will be 0 at x is equal to L by 2 and T maximum is Ts plus Q dot L square by 8K. If Ts1 is not equal to Ts2, then T maximum can be calculated by either Ts1 plus Q dot by 8K into 2L1 square, isn't it? Or we can write it as Ts2 plus Q dot by 8K into 2L2. It should be whole square, na? 2L1 whole square, 2L2 whole square. So this is the expression. If we draw for Ts1 is equal to Ts2, the parabola will be symmetrical about the mid plane because this is also Ts, this is also Ts. So it is the maximum temperature is at x is equal to L by 2. But if Ts1 is not equal to Ts2, if Ts1 is less than Ts2, then the parabola will be something like this. So this is the point of maximum temperature. Here the temperature will be maximum. This distance is, let us say, L1. This distance is L2. So by using L1, L2, Ts1, Ts2, we can find out the expression for maximum temperature. And Q will be 0. Where the temperature is maximum, Q will be equal to 0. Q will be equal to 0 because dt by dx is 0. The direction of heat flow will be towards left also, towards right also. Direction of heat transfer will be left and right in both the sides. In case of a solid cylinder, with heat generation, T is equal to Ts plus Q dot by 4K into capital R square minus small r square. It is parabola. And Q is a function of R square. Q is a function of R square. Q will be function of R square. And at R is equal to 0 center, temperature will be maximum. That is equal to Ts plus Q dot capital R square by 4K. If it is a solid sphere with heat generation, then T is equal to Ts plus Q dot by 6K into capital R square minus small r square. It is also parabola. And Q is a function of R cube. And at R is equal to 0, temperature is maximum, that is Ts plus Q dot by 6K into R square, where Q dot is watt per meter cube, that is rate of uniform heat generation per unit volume, right? So the correct answer to the given question is option C. This is for solid sphere. This would have been for a solid sphere. And Q dot L square by 8K, there is no R. Q dot L square by 8K would have been for a plane wall, right? The next one. Get me the answer for the next question, everyone. The heat flow through a composite cylinder is given by the equation. Yes, for a composite cylinder. The question is about a composite cylinder. Composite cylinder is a cylinder made up of more number of materials. So what we can say, for a composite system, we can analyze. This would have been the answer for option A is the correct answer, isn't it? And this would have been for a composite sphere. This would have been for a single cylinder, single hollow cylinder. And this is for a composite wall, composite plane wall, composite plane wall. Let us try to understand the composite system. Q, which is equal to delta T upon thermal resistance, can be written as U into A into delta T overall. That remains constant. So from here we can say U is equal to 1 upon A into thermal resistance. For a composite, U is the overall heat transfer coefficient. This is, hi Arnab, good morning. I am all fine. How are you? Overall heat transfer coefficient. And what is the thermal resistance? If there is a convection also, then it will be 1 by A, 1 upon Hi plus summation of J is equal to 1 to N Lj by Kj plus 1 upon H naught. If there is no convection given, then we can, so delta T upon RTH will give you Q. Or if you want to find out the thermal resistance, then this will be the expression for a plane wall. This was for a plane wall or composite wall, sorry. This is the expression for a composite wall. For a composite cylinder, कौन सी इवनिंग पेजल वर्ल्ड 50 मार्क्स सीरीज की बात कर रहे हैं क्या? फ्री क्लास की बात कर रहे हैं या फिर पेड क्लास की बात कर रहे हैं? For a composite cylinder or composite sphere, there will be 2Q delta T upon thermal resistance is equal to Ui into Ai into delta T or U0 into A0 into delta T. हाँ 5 बजे ना पेजल वर्ल्ड, 5 बजे की बात कर रहे हैं ना, 50 mark series. Yes, there will be a class at 5. So that remains constant as long as the conduction is one dimensional steady state and no heat generation. यहां से Ui को लिख सकते हैं 1 upon Ai into R equivalent. This is R equivalent. Let me write it as equivalent thermal resistance. Equivalent thermal resistance. And U0 is equal to 1 upon A0 into R equivalent. Ai and A0, Ai is equal to 2 pi R1L for a cylinder and A0 will be equal to 2 pi R n plus 1 into L. And for a sphere, this is for a cylindrical system, and for a spherical system it is 4 pi R1 square and A0 will be equal to 4 pi Rn plus 1 square for a sphere, right? And R equivalent for a cylinder, is equal to 1 upon 2 pi L, then 1 upon Hi into R1 plus summation of j is equal to 1 to n, then ln of r j plus 1 upon rj upon kj, then plus 1 upon h naught into rn plus 1. This is the expression for a cylinder, and R equivalent for a sphere will be equal to 1 upon 4 pi, then 1 upon hi into r1 square plus summation j is equal to 1 to n, then rj plus 1 minus rj upon kj, rj plus 1 upon h naught into rn plus 1 square. These are the expression for equivalent thermal resistance for a composite cylinder as well as composite sphere. I hope this is clear. So the session is about the revision of the important formula. The next question on your screen. Simple question hai. The next one. 3 metal walls of the same cross-sectional area having thermal conductivity in the ratio 1:2:4 transfer heat at the rate of 6000 kilojoule per hour. For the same thickness of the wall, the temperature drops will be in the ratio. What will be the answer? So we can say Q is equal to Ka delta T by L remains constant because the walls are in series. For series combination, Q will remain constant. So the thermal conductivity thicknesses are same, cross-sectional area is same. So we can say delta T is inversely proportional to thermal conductivity. So delta T1 is to delta T2 is to delta T3 is equal to 1 upon K1 is to 1 upon K2 is to 1 upon K3. So 1 ratio 1 upon 2 ratio 1 upon 4. B will be the correct answer. Yes, Arnab, Pejal, Naruto, well done Vinay, good. So whenever the resistances are connected in series, for series combination, Q will remain constant. Q will remain constant. And delta T, overall thermal potential will be delta T1 plus delta T2 plus delta T3 and so on. So equivalent thermal resistance will be sum of R1 plus R2 plus R3 and so on. So from here delta T1 by delta T2, from here we can write delta T1 by delta T2 is equal to R1 by R2. That is for the series combination of thermal resistances and if the resistances are connected in parallel. If the thermal resistances are connected in parallel, then Q will be Q1 plus Q2 plus Q3. Overall thermal potential is same as the thermal potential across the resistance 1 or resistance 2 or so on. Delta T remain constant. So 1 upon equivalent thermal resistance will be 1 by R1 plus 1 by R2 plus so on. So from here Q1 by Q2 can be calculated by R2 by R1. Q1 by Q2 is equal to R2 by R1 for parallel resistances, right? The next topic is, after this conduction, there is an important topic, very small topic regarding the insulation. We can increase the rate of heat transfer using the insulation in case of radial system. The method of insulation is only applicable in case of radial system. What is the answer to this one? The formula for critical radius of insulation in case of a sphere. It is in case of a sphere. It will be 2K by H. If it would have been a cylinder, then it would have been K by H. For the radial system, up to RCR, critical radius of thickness, the Q will become maximum. So the RCR for a cylinder will be equal to K insulating material, H outside. and RCR for a sphere will be equal to twice of K for the insulating material upon heat transfer coefficient of the medium in contact with the insulating material. Sometimes thickness of insulation is also asked. TCR is equal to RCR minus R naught. That is called as critical thickness of insulation, which gives the maximum heat transfer rate. Critical thickness. सिंपल है ये तो, बट एक चीज कई बार पूछी जाती है. दिस इज द ओरिजिनल रेडियस लेटर से फॉर ए रेडियल सिस्टम. दिस इज लेटर से R naught एंड this is let us say RCR. This is let us say RCR, critical radius. So when the radius is equal to critical radius, the heat transfer rate will become maximum and then it will decrease. Here Q will be maximum. So the question asked is, if R naught is less than RCR, if R naught is less than RCR, then increasing the thickness, as R increases, then Q will increase, then become maximum. At RCR, Q will become maximum, and then if further increase in R, will start decreasing the value of Q. Q will decrease, isn't it? Q will start decreasing. But if R naught is greater than equal to RCR, if R naught is same as RCR or greater than RCR, then if R increases, the rate of heat transfer will decrease continuously. Then the rate of heat transfer will decrease continuously. Do you understand this? So without insulation, this is Q. Without insulation, yeah, Q bare. Then there is an increase in Q, it is maximum corresponding to RCR, this is corresponding to R naught, and then further increase in radius of insulation will decrease the value of Q beyond RCR. So there is another series which is running on BYJU'S exam prep for your efficient preparation. Those who are preparing for GATE 2024 examination, today at 5 p.m. I will be having a session on thermodynamics. I will talk about heat and work. Energy interaction today at 5 p.m. on your favorite YouTube channel. Alright. So do not forget to join me today at 5 p.m. Let us move to the next topic in conduction, that is fin theory. The next topic is fin theory, and most important is very long fin. So there are various parameters related to very long fin on list 1 and the formula are there in list 2. Can you let me know the answer to these questions? For A is the temperature profile. A is the temperature profile. B is the rate of heat transfer from the fin, and C is thermal efficiency of the fin, that is thermal performance parameter, and the next one is the effectiveness of the fin, that represents the economic performance of the fin. Bataiye, for very long fin, when do we call the fin to be very long? If M into L is greater than equal to 5. We can assume very long fin. What is M here? M is under root of HP by K into cross-sectional area. That is called as, the unit is meter inverse, which is called as fin constant. When M into L is greater than 5, we can call it as very long fin. So this is the temperature profile T minus T infinity upon Ts minus T infinity, that is theta by theta s, is given by e to the power minus mx. The variation is exponential. M is under root of Hp by Ka. P is the perimeter, K is the thermal conductivity, AC is the cross sectional area. A2, right? X is the distance from the root of the fin. Then Q fin, heat loss from the fin, that is given by Ka m theta s, isn't it? or we can write it as under root of HP K into AC into theta S. What is theta S? Theta S is Ts minus T infinity. So Q fin is directly proportional to root K. It will not be proportional to K because there is a M. Fin constant is there. So put the value of fin constant, that is under root of HP by Ka, then you will get the expression for Q fin like this. The third one is fin efficiency. What is the efficiency of the fin? That is the ratio of Q fin upon Q maximum. Maximum heat loss from the fin. And the value of Q maximum is when the entire fin is maintained at the base or the root temperature. So in that case, it will be H into PL into theta S. So if you divide these two, you will get the expression for Q fin as 1 upon M into L. And the efficiency of the fin or effectiveness of the fin is given by the expression. What is effectiveness? That is the ratio of Q fin to the Q without fin or Q bare. When there is no fin attached, so Q without fin, Q bare is given by H into AC into theta S when there is no fin. So if you take the ratio, you will get the effectiveness of the fin as Km by H. And effectiveness of the fin can have the value less than 1, can have the value equal to 1, can have the value greater than 1. Whereas the efficiency of the fin is always less than 1. So A2, B4, very nice, C3 and D1. Well done, Arnab. 4-3, 2-4-3-1, 2-4-3-1. Vinay, good. But if the fin is short, if there is a short fin with insulated tip, what is the nature of temperature profile for a short fin with insulated tip? Can you find out when N is finite? What is the temperature profile? Theta upon theta S is equal to cos hyperbolic M L minus X upon cos hyperbolic ML. That is hyperbolic function. The nature of the temperature profile is hyperbolic for a short fin with insulated tip. And if we find out theta minimum upon theta S, then it will become 1 upon cos hyperbolic ML. Right? And Q fin is equal to KAM theta S into 10 hyperbolic ML. It is a hyperbolic function. Efficiency of the fin will become 1 upon ML into 10 hyperbolic ML. Effectiveness of the fin will be equal to Km by H into 10 hyperbolic ML. These are the expressions, these are the formula for the short fin with the insulated tip. When there is a short fin with free tip, short fin with free or convecting tip, when there is a convection from the tip, then what we will do is L will be replaced by characteristic length, correction length. L will be replaced by correction length. And what is the correction length? L will be replaced by correction length and assume it as short fin with insulated tip. Replace the value of L with LC and use the formula for short fin with insulated tip. What is the correction length? Correction length is equal to L plus the ratio of cross sectional area by perimeter, L plus A by P. So we can say theta upon theta S will be equal to cos hyperbolic M LC minus X upon cos hyperbolic M LC. This will be the formula for temperature profile. We can again call it as hyperbolic function. It is also hyperbolic. I hope this is clear. So these are the various parameters regarding the fin theory. Yes, Arnab, this will be hyperbolic. So these are the three cases we analyze in case of, and the last part, last topic in the conduction is lump system analysis or unsteady state conduction. So what is the formula for this? For unsteady state conduction, what is the formula? Temperature versus time. Unsteady state means when the temperature becomes a function of time. T is for temperature and tau is for time. T is for temperature, tau is for time. So what do you understand by the term lump system analysis? When do we have the lump system analysis? When the conductive thermal resistance is R conduction, conductive thermal resistance of the solid is less than equal to 1/10 of convective thermal resistance of the fluid. Or we can say when the Biot number is less than 0.1, then we can assume the system to be lump system. The analysis will be lump system analysis. And for the lump system analysis, theta upon theta I is given by, what is the correct answer? B will be the right answer for this one. क्या फॉर्मूला याद रखने फॉर लंप सिस्टम एनालिसिस? व्हेन बायोट नंबर इज less than 0.1, in that case theta upon theta I, that is T minus T infinity upon Ti minus T infinity, is equal to e to the power minus HA is the surface area available for heat transfer, HA by rho into C into volume into tau, that is written as E in minus B into tau, or e to the power minus tau upon tau star. What is tau star? Tau star is called as time constant of the thermocouple, or we can write it as e to the power minus Biot number into Fourier number. This is the expression when we assume the system to be lump system, where tau star, that is equal to rho CV by H into surface area, the unit is second, is called as time constant, is called as time constant, which is 1 by B. B is the thermal response. Biot number is equal to the ratio of conductive thermal resistance in the solid to the convective thermal resistance in the fluid, and the expression will be H into LC by K, HLC by K, K for the solid. What is LC? LC is equal to volume per unit surface area, and the Fourier number is given by Q conduction upon Q stored, the ratio of heat transferred due to conduction to the heat stored, that is alpha into tau upon LC square, where alpha is equal to K by rho C, rho into C. These are the various formula for analyzing the lump system analysis. For analyzing the unsteady conduction when the Biot number is less than 0.1. Yes, the Biot number is, what is the answer for this one? Next one, Biot number, alpha tau by LC square is Fourier number, HLC by K, that is the Biot number, and which is the ratio of R conduction to R convection. It is MSQ actually. It is MSQ. So B and C. B and C are the correct answer. It would have been A. Biot number should have been Q convection upon Q conduction. So option A is the one by Biot number. It is the reciprocal of Biot number. So A is not correct. A is not correct. B and C are the correct answer. And we can find out the rate of heat transfer Q tau. If Biot number is If Biot number is less than 0.1 for the lump system analysis, Q to H into A into T minus T infinity, or minus rho CV into dt by dt. Isn't it? And Q maximum can be calculated as maximum heat loss between the time interval 0 to tau is equal to rho CV, or M into C into Ti minus T infinity. Q maximum is M into C Ti minus T infinity. That is the maximum heat loss, right? The unit of this expression is joule. This is joule per second or watt, exponential. Let us move to the heat exchanger now. Let us move to the heat exchanger. The LMTD for a counterflow heat exchanger is given by, the next one is LMTD for a counterflow heat exchanger. What is the correct answer for this one? For a counterflow heat exchanger, the two fluids flow opposite to each other. What is LMTD? Is equal to delta Ti minus delta Tf upon natural log of delta Ti by delta Tf. This is the formula for LMTD. If it would have been a parallel flow heat exchanger, for a parallel flow heat exchanger like this is hot fluid, this would have been cold fluid, this is TH1, this is TH2, TC1, TC2. So delta Ti would have been TH1 minus TC1, delta Tf would have been delta Tf would have been, this would have been delta Tf. So we could have put the values here, Th1 minus Tc1 minus Th2 minus Tc2 upon natural log of delta Ti by delta Tf. If it would have been counterflow heat exchanger, this is hot fluid, this is cold fluid. For a counterflow heat exchanger, what is delta Ti? For a counterflow heat exchanger, this is Th1, this is Th2, this is Tc1, this is Tc2. This distance is delta Ti and this will be delta Tf. So the expression for counterflow heat exchanger, LMTD expression for counterflow heat exchanger will be Th1 minus Tc2 then minus Th2 minus Tc1 upon natural log of Th1 minus Tc2 upon Th2 minus Tc1. This is for counterflow heat exchanger. Option A is for parallel flow heat exchanger. Option A is for parallel flow heat exchanger. This is for parallel. Isn't it? And for counterflow heat exchanger or for balanced counterflow heat exchanger, if it would have been balanced counterflow heat exchanger, what is the meaning of balanced counterflow heat exchanger? When the product of mass flow rate into specific heat for the hot fluid is same as the product of mass flow rate into specific heat of the cold fluid. Capital CH, capital C is mass flow rate into specific heat. That is heat capacity rate. If the heat capacity rate of the hot fluid is same as the cold fluid, then the temperature profile would have been straight line. They are parallel and straight line, hot fluid and cold fluid. So LMTD will be Th1, this is Tc2, this is Th2, this is Tc1. Either we write the LMTD to be Th2 minus Tc1, that is LMTD, or we can write LMTD as Th1 minus Tc2. LMTD will be calculated by taking the difference of TH1 minus TC2 or TH2 minus TC1. All right. This is for the LMTD. So the rate of heat transfer can either be calculated by CH into delta TH or CC into delta TC, or we can write it as U into A into mean temperature difference, that is LMTD, or effectiveness into Q maximum, that remains constant. That is called as heat load or thermal capacity of the heat exchanger. Capital CH is the heat capacity rate of the hot fluid. Delta TH, what is delta TH? Delta TH is TH1 minus TH2. Delta TC is TC2 minus TC1. Delta TM we have already discussed. This is LMTD. And what is effectiveness? Effectiveness is the ratio of Q by Q maximum. So Q maximum is equal to C minimum into TH1 minus TC1, where C minimum is equal to minimum among CH and CC. That is Q maximum. And effectiveness is given by Q upon Q maximum. That is the effectiveness of the heat exchanger, right? Capital CH is equal to mass flow rate of hot fluid into specific heat of hot fluid, and capital CC is the product of mass flow rate of the cold fluid into specific heat of the cold fluid, right? And there is another expression in terms of NTU, effectiveness in terms of NTU. Do you know how to write the effectiveness in terms of NTU? The next question is regarding that only. Effectiveness in terms of NTU. Can you solve it? Can you let me know? For a parallel flow, what is NTU? NTU is given by, which is denoted by N, UA by C minimum. Again, C minimum is the minimum among CH and CC. Yes, for a parallel flow heat exchanger, effectiveness is given by 1 minus E to the power minus N 1 plus C upon 1 plus C. For a parallel flow heat exchanger. For a counter flow heat exchanger, the expression is 1 minus E to the power minus N 1 minus C. What is C here? Where C is C minimum by C maximum. That is heat capacity ratio. Ratio of heat capacities. It is not the ratio of specific heats. It is the ratio of heat capacities. Then for C is equal to 1. When C is equal to 1? C is equal to 1 if CH is equal to CC or delta TH is equal to delta TC. Then it will be C is equal to 1. If C is equal to 1 for parallel flow, put the value C is equal to 1 in case of parallel flow heat exchanger. For parallel flow, this is the formula for parallel flow. If you put C is equal to 1, then the expression will be this. And C is equal to 1 for counter flow. If you will put the value C is equal to 1 for counter flow, you will get 0 by 0 form. For counter flow, for balanced counter flow heat exchanger. For balanced counter flow heat exchanger, what does that mean? CH is equal to CC or C is equal to 1. Then you will use L'Hospital rule. And effectiveness is given by NTU upon NTU plus 1. That is the formula. And for C is equal to 0, it means either it is a condenser if there is a phase change, or evaporator, or cascade heat exchanger. Then for C is equal to 1, parallel flow, counter flow and cross flow are having the same 1 minus e to the power minus n. 1 minus e to the power minus n will be the expression. That is for C is equal to 0. So the answer will be 2, 3, 4, 5. For the given question, the answers will be 2, 3, 4, 5. I hope this is clear. These are the formula you should have an idea of for getting your answer correct. The balanced counter flow heat exchanger is very, very important from your examination point of view. Can you just solve this question? Yes, every one of you, please give it a try. So I will share the PDF of this session to my Telegram channel. Okay. So go through this PDF to revise the important formula which will help you to get the better score in your ISRO 2023. And do not forget to join me today at 5 p.m. for the numerical practice session for thermodynamics, and the topic will be energy interaction in the form of heat or in the form of work. What is the answer? Look, if we say in a certain heat exchanger both the fluids have identical mass flow rate and specific heat product, it means it is a balanced. It is balanced heat exchanger. CH is equal to CC, that is given. The hot fluid enters at 76 degrees Celsius. Hot fluid enters at 76 degrees Celsius. So TH1 is equal to 76 and leaves at 47. TH2 is, what is delta TH? 76 minus 47. 29, isn't it? And if the cold fluid entering at 26, TC1 is equal to 26, TC2 is equal to 55. What is this difference? Sorry, this is also 29, na? So delta TC will also be 29. Now what we need to find out, because CH is equal to CC, and then we need to find out the effectiveness. What is the effectiveness? That is Q actual by Q maximum. So Q actual, we can either write it as CH into TH1 minus TH2. Here it will be C minimum into TH1 minus TC1. C minimum and CH. C minimum will either be CH or CC because it is a balanced counterflow heat exchanger. So 29 divided by TH1 minus TC1. 76 minus 26. What is this? 29 divided by 50, isn't it? (29 divided by 50). What is the answer? Are you getting option B or not? 0.58. It is close to 0.58. It is something around 3 by 5. Around 3 by 5. 0.6. It is close to 0.6. So 0.58 is more appropriate answer. Alright. So this is your assignment question. Try to solve this question and share your answer to my Telegram channel or in the comment section. Alright, so do not forget to like and share this session, guys. Thank you very much for joining in. Let me take your leave now. You can always connect with me through that mail ID, or you can join me on the Telegram if you are not part of my Telegram channel yet. So with this note, let me take your leave. And there are some important series which are running on our BYJU'S platform. One is Sunday Ka Funda series. Every Sunday we bring the concept in the interesting manner for you to understand with the practical applications, and another is the Super Saturdays for knowing the legends as well as the Raftar series. All right, so that is all from my side, guys. Thank you for joining in. Have a great day and see you at 5 p.m. in the evening on the same platform. Till then, enjoy, take care, have a good day and a great career ahead. Jai Hind.